Okay, so number 1 wants us to determine which quadrant each of these angles lie in. So letter A, 292 degrees. Well, that lies between 270 and 360, so that would be in the 4th quadrant. All right, in letter B, they give us a negative angle. So in order to make it positive, what we want to do is we want to add 360 to it. So if we do negative 120 plus 360, we wind up getting 240 degrees. Now 240 is in between 180 and 270, so that's going to be in the 3rd quadrant. Okay, in letter C, we're given a very big angle. So what we want to do is we want to subtract off 360 as many times as we have to in order to find an angle that's between 0 and 360. Okay, so you could see what I did was I took the 1290 and I subtracted off 360. And it still left us with an angle that was too big. So I subtracted off another 360. And it still left us with an angle that was bigger than 360. Remember, we're trying to form an angle between 0 and 360. So I subtracted off another 360, and finally I got an angle between 0 and 360. I got 210 degrees. So 210 is in between 180 and 270. So that, just like letter B, would also be in the 3rd quadrant. All right, now if we take a look at letter D, they give us a negative angle. And if you recall with negative angles, okay, just like in letter B, we're going to add on 360. Now in this case, you're going to have to add on 360 more than once. You're going to have to add it on until we form a positive angle between 0 and 360. Okay, so if you notice, when I added on 360 to the negative 815, it was still negative. So I added on 360 again, and it was still negative, so I had to do it a 3rd time. And when I did it a 3rd time, I finally had an angle between 0 and 360. Now, more specifically, this angle is between 180 and 270. So in letter D, we are again in the 3rd quadrant. Okay, now with letter E, you could see that it's written in terms of radians, okay? We're given 19 pi over 3. I'm just going to squeeze this in over here. So in order to change to degrees, we want to multiply it by 180 over pi. Okay, so this pi cancels out with this pi, and then we're going to figure out, I like to do 180 divided by 3 is 60, and then I just figure out what 60 times 19 is. And that's actually a big angle. That's going to give us 1,140, which is a big angle, right? So what we're going to do is we're going to subtract off 360 as many times as we have to in order to find an angle between 0 and 360. Okay, so you could see here I had to subtract off 360 3 times in order to get an angle that was between 0 and 360. And when I did, I wound up with a 60-degree angle. So we could see that 60 is in between 0 and 90, so that's going to be in the 1st quadrant. Okay, and then finally part F, actually I'm going to write this down here. We have negative 3 pi over 4. So that's in radians, so we have to change that to degrees. So we're going to multiply by 180 over pi. Okay, so the pi on top cancels with the pi on bottom. And let's see, 180 divided by 4 is 45. 3 times 45 is 135, so this is going to be negative, right? Don't forget to put the negative there, negative 135. Now, if we have a negative angle, we make it positive by adding on 360. So when we add on 360, that gives us positive 225. All right, so 225 is between 180 and 270, so we are in the 3rd quadrant. Okay, so for number, it looks like 2 and 3, we're going to need to use, I'll put it over here, all students take calculus. And keep in mind, so everything, right, all is positive in the 1st quadrant. In the 2nd quadrant, sine is positive, but also its reciprocal trig function, which is cosecant, is positive. Okay, in the 3rd quadrant, tan is positive, but also its reciprocal trig function of cotan is positive. And then in the 4th quadrant, cosine is positive, but so is its reciprocal trig function, which is secant. Okay, so that being said, let's see. Number 2, if tan is less than 0, So tan is negative. All right, well, if tan is positive in quadrant 1 and 3, it has to be negative in quadrants 2 and 4. And here, this says that cosecant is less than negative 2. So if cosecant is less than negative 2, it's definitely a negative number. So cosecant matches up with sine. So sine is positive in the first and second, so it's negative in the third and the fourth. All right, so the quadrant that they have in common is right here, okay? So quadrant 4 is our answer. All right, for the next one, it says here, if sine is less than 0. So we just said sine is negative in the third and fourth quadrant, right? Because it's positive in the first and second. So sine's negative in the third and fourth quadrant. Now this part's a little tricky. It says sine times cosine is greater than 0. Well, when you multiply two values, in order for them to be greater than 0, in order for them to be positive, they have to have the same sign. So what that means is they're either both positive or both negative. Okay, so let me say that again. When you multiply two values, in order for them to be greater than 0, in order for them to be positive, they have to have the same sign. So we're looking for where cosine and sine are both positive, and then also for cosine and sine are both negative. Well, let's think about it. In the first quadrant, everything's positive, right? So they're both positive in the first quadrant. Everything's positive there. So they have the same sign. In the third quadrant, this is where they're both negative, right? Because the only two trig functions that are positive are tan and cotan. So then if we look and say, well, look at this. Quadrant 3 is the one that satisfies both conditions. So quadrant 3 is our answer. Okay, number 5. Convert 570 degrees to radians. All right, so to convert from degrees to radians, all we do is multiply by pi over 180. All right, I'm going to put this over 1. So if we multiply straight across, 570 times pi is 570 pi. And then 1 times 180 is 180. Now we're going to leave it in terms of pi. The only time you don't leave it in terms of pi is if they say to round to the nearest, whatever, like 10, 100th, whatever it is. So basically we're just simplifying 570 over 180. Or you could simplify 57 over 18. Well, 57 divided by 18, they're both divisible by 3, right? 57 divided by 3 is 19. And 18 divided by 3 is 6. And then I'm just going to take the pi and bring it over. So it leaves us with 19 pi over 6. If you wanted to, use your calculator to check this, you could always type in 570 divided by 180 and hit math, enter, enter, and it'll give you 19 over 6. Just be sure not to plug the pi in your calculator. All right, number 5. Christine is riding in car 4, here she is, of the Ferris wheel represented in the accompanying diagram. The Ferris wheel is rotating in the direction indicated by the arrow, so it's going this way. Okay, so she's cruising around that Ferris wheel sitting backwards. Okay, so the 8 cars are equally spaced around the circular wheel. Express in radians the measure of the smallest angle through which she will travel to reach the bottom of the Ferris wheel. Well, I mean, since it's going this way, right, she's got to travel all the way around until she gets to here. So basically she's going from here to there. So we want to figure out how many degrees she just rotated. Well, we know that a circle is 360 degrees, right? And if there's 8 cars and they're equally spaced apart, then let's do 360 divided by 8, which is 45. And what that means is that each, let me change colors here so it's not blending in. It means that between car 4 and 3 is a 45-degree angle. Between car 3 and 2 is a 45-degree angle. Between each of these, there's a 45-degree angle. Okay? I mean, you don't have to write all this out. Basically, we have 5 45-degree angles. So if we take the 45 and multiply that by 5, we get 225. So she's traveled 225 degrees. Now they want us to express that in radians. So just like number 4, in order to convert from degrees to radians, you take it and you multiply by pi over 180. Okay, so now if I multiply across, I get 225 pi over 180. And then we're just going to simplify these numbers. So we should kind of, we should be a little familiar with these numbers at this point. Like we should know that both of these are divisible by 45, especially since we got them, right? We got this by multiplying by 45. So if you take 225, basically I want to simplify this fraction. So if I take 225 and divide it by 45, I get 5. And if I take 180 and divide it by 45, I get 4. So 225 over 180 simplifies to 5/4. And the reason I staggered it like this is because I needed to make room to bring this pi down. So it leaves me with 5 pi over 4. Again, if you want to check in your calculator, you could type in 225 divided by 180, math, enter, enter, and it will give you 5/4. And then you just bring the pi down, okay? Don't plug the pi in your calculator. Okay, so in number 6, they want us to determine the exact value of each of the following. Okay, so if we take a look at letter A, first thing we have to do is we have to convert this to degrees. So I'm going to multiply by 180 over pi. All right, so this pi on top cancels with the pi on bottom, so I could rewrite this as secant of, and don't forget to bring down that negative sign. Well, 180 divided by 4 is 45, and 5 times 45 is 225. Okay, so now this is a negative angle. So we want to make it positive by adding 360, right? We want to add on a full circle and still end up in that same spot. So I'm going to bring down the secant. I'm going to keep bringing down the equal sign. So this is equal to secant of negative 225 plus 360 is 135. All right, now I'm going to do my thinking off to the side here. And I want to show what I'm thinking, right? You want to show all your work on a test or a quiz. Okay, so 135 is in the second quadrant. So if we think about all students take calculus in the second quadrant, sine is positive, as well as its reciprocal trig function, which is cosecant. So secant is not positive in that quadrant, so secant is negative. So the first thing I'm going to do is I'm going to rewrite this as negative secant. And be sure to show this step. All right, now we have to find the reference angle that corresponds with an angle of 135 degrees. So if we're in the second quadrant, the reference angle rule is 180 minus theta. So if I do 180 minus 135, that is going to give me 45 degrees. So I'm going to rewrite this in terms of its reference angle. Okay, and I just want to point out all of these steps are equivalent. Secant of negative 5 pi over 4 is equal to secant of negative 225, which is equal to secant of 135, which is equal to negative secant of 45. Okay, now what I'm going to do is I'm going to bring down my negative sign. I'm going to bring down the equal sign. I'm going to bring down the negative. And secant is the reciprocal of cosine. Since cosine of 45 is radical 2 over 2, I'm going to take that and flip it upside down. So I'll have 2 over radical 2. All right, we don't want to leave our answer with a radical in the denominator, so I'm going to rationalize it. I'm going to multiply the top and bottom by radical 2. All right, so this equals, let me bring down the negative sign. 2 times radical 2 is 2 radical 2. And then in the denominator, radical 2 times radical 2 is just 2. And when this 2 on top cancels with 2 on bottom, it's going to leave us with just negative radical 2. All right, let's come on over here to letter B. Cosecant of 690. Now 690 is too big, so let's subtract off a full circle. Let's subtract off 360 degrees. And when I do, that's going to leave me with cosecant of 690 minus 360 is 330 degrees. Okay, so I'm going to think off to the side to myself. So 330 degrees is in the fourth quadrant. And if we say all students take calculus, cosine is positive in the fourth quadrant, as well as its reciprocal trig function of secant. So cosecant isn't one of those two trig functions, so cosecant is negative. All right, so that being said, let's come back over here and let's rewrite this as negative cosecant. And please be sure to put the negative in front of the trig function. It's the trig function that's negative. Some of you were putting it in front of the angle. We don't want to create a negative angle. Okay, So now we have to figure out what fourth quadrant, right, since we're in the fourth quadrant, what fourth quadrant reference angle corresponds with an angle of 330 degrees. Well, a reference angle rule in the fourth quadrant is 360 minus theta. So if I do 360 minus 330, right, that's our fourth quadrant angle of theta, that gives us 30. So now I'm going to come back over here, and instead of 330, I'm going to write it as its reference angle. Okay, so we have, all said and done, negative cosecant of 30. All right, so let's bring down the negative. And since a cosecant is reciprocal of sine, let's think about what sine of 30 is. Well, sine of 30 is 1/2. So if we flip that upside down, it would be 2 over 1, which is just 2. So that's it. That's our answer for letter B. All right, letter C. Now, first thing, again, they give it to us just like in letter A. They give it to us in radians. So to change that to degrees, we're going to multiply by 180 over pi. So actually, look what happens. This pi on top cancels with this pi on bottom. So I'm going to bring down cosine of, and this time it's the angle that's negative, not the trig function. So cosine of negative 180. Okay, so I'm going to make that angle positive by adding on a full circle. And that's going to leave me with cosine of negative 180 plus 360 is 180. Now, whenever you have a quadrantal angle, so 0, 90, 180, 270, 360, we're not in a quadrant. So what you have to do is you have to think about our unit circle. So here's our unit circle, right? And this would be 0 degrees, 90 degrees, 180 degrees. So this is where 180 degrees lies. So we're concerned with this point right here. Okay, this is where 180 degrees is. So the coordinates of this point, since we went back 1 and up 0 to get to it, would be negative 1, 0. Okay, so that's a negative in there. So cosine is the x-coordinate. So the x-coordinate here is negative 1. So what that means is cosine of 180 is equal to negative 1. Okay, and then finally, the last one that we have to do is letter D. So now letter D says sine of negative 5 pi over 2. Okay, so let's again convert this to degrees by multiplying by 180 over pi. So what happens is the pi on top cancels with the pi on bottom. So this is going to be equal to sine of, we have a negative sign, and then you're just going to figure out what 5 times 180 divided by 2 is. So 180 divided by 2 is 90, and 5 times 90 is 450. So we have sine of negative 450 degrees. Okay, so since we have a negative angle, we know we add on 360, right? We're trying to make it positive by adding on full circles. When we add on positive 360, we're still at a negative angle. We're still at negative 90. So I have to add on another 360. So when I add on another 360, right, you got to keep going until it becomes a positive angle between 0 and 360. I get 270. So this is sine of 270. Okay, now again, just like the last one, this is a quadrantal angle. It's not in a quadrant, it's on one of the axes. So when that happens, we draw out the unit circle. And let's think about where 270 degrees is. If you go 90, 180, 270, this down here is where 270 degrees is. Okay, so we're concerned with the coordinate at this point. So to get to that point, we go over 0 and down 1. So over 0 and down 1 gives us the coordinate 0, negative 1. Okay, this time we're looking for sine. Sine is the y-coordinate. So the y-coordinate at 270 degrees is negative 1. So negative 1 is what sine of 270 is equal to. All right, so let's take a look at number 7. It says a wheel has a radius of 18 inches. All right, so I'm going to draw this out. So I have a wheel, and its radius is 18 inches. Okay, determine the distance to the nearest inch the wheel travels when it rotates to an angle of 120 degrees. Okay, so we know that if we were to have a 90-degree angle, it would look like this, right? This is a 90-degree angle, so figure 120 degrees would be a little bit more. It'd be like right over here. So I'm going to do this, and this will be 120 degrees. And we want to know the distance the wheel has traveled. So it's going to travel from here to here, which we know when we're looking at a picture like this, that is going to represent S, right? We're going to use S equals R theta, right? This is the S that we're looking for. The R is the radius, and the theta is the angle. Okay, so I'm going to rewrite this as S is what we're looking for. R is the radius, which is 18 inches. Now theta, it's when we plug it in, it's important that we convert it to radians. So if we have 120 degrees, right, we're going to multiply this by 120 degrees times, well, to convert to radians, we multiply by pi over 180. Now, I know some of you guys like to first simplify this, right? 120 over 180 is 2/3, so 2 pi over 3. You can do that if you want, but you don't have to, because you're going to be plugging this in your calculator anyway, because they want you to take it and round it. See how they say write it? They want you to write your answers to the nearest inch. So since you're plugging that in your calculator anyway, it's kind of just creating an extra step for yourself that you don't have to do if you want, if you simplify this. Okay, so when you plug in 18 times 120 pi over 180, it gives us S to be like 37.6991. Okay, so to the nearest inch, that means the nearest whole number. So to the nearest whole number, that would be 38, and the units would be inches. And don't forget to put your units, okay? You don't want to just leave it at 38. Always put those units. Okay, number 8, I'm going to draw this one out too. A circle is drawn to represent a pizza with a 12-inch diameter. Okay, so we have a circle, this is our pizza. And it's a 12-inch diameter. So from there to there is 12. Okay, before I label that, I just want to read a little more first. The circle is cut into 8 congruent pieces. So that means we have 8 completely equal slices of pizza. There we go. All right, what is the length of the outer edge of any one piece of this circle? All right, so we're looking for the outer edge, like the crust of one piece, from there to there. Now, we're going to use our formula S equals R theta. So this is the S. Now, the R, the radius, if the diameter is 12, right? The diameter is the length from one edge of the circle all the way across to the other edge. So if the diameter is 12, wouldn't the radius just be half of that, which is 6? All right, so our radius is going to be 6 inches. Okay, and then, so let's write this. S equals R theta. Okay, we're looking for the S. The radius is 6. And then our angle. Well, they don't come out and give us our angle, but let's think about this. The reason they said that they cut these into 8 equal slices or congruent pieces is because if you take a full circle, which is 360 degrees, and divide that into 8 equal sections, that means that each section must have an angle measure, right here, of 45 degrees. Now, just like in the last problem, this formula, right, the angle has to be in radians. So to convert from degrees to radians, you just take this and multiply by pi over 180. So you're going to do 45 times pi over 180. I plug it in right like that. If you want to simplify this to 1 pi over 4, so just pi over 4, you can. And to be honest, actually in this case, because they don't say to round, I'm going to do that. If they had said to round to the nearest tenth or whatever, I would just plug this in my calculator, just like I see it. But because they're not saying to round, we have to figure out, we want to write the exact length of the outer edge of one piece of pizza. So I'm going to bring down the 6. And this right here, right, 45 divided by 180, well, they're both divisible by 45. 45 divided by 45 is 1, and 180 divided by 45 is 4. So this will be 1 pi over 4, which is really just pi over 4. Okay, so then I'm going to take the 6 and put it over 1, so that we have a fraction being equal to another fraction. So here, S is going to be equal to, and just multiply across. 6 times pi is 6 pi, and 1 times 4 is 4. So we get 6 pi over 4. Now, the only other thing that you have to do, right, you always want to simplify a fraction if you can, is simplify this. And since 6 over 4 simplifies to 3 over 2, we could write this as 3 pi over 2. Okay, that's the length of the outer edge of the pizza. And I'm just going to write inches, I guess. That's our unit. That's our units for this. All right, next one, number 9. So if the terminal side of an angle theta, of angle theta in standard position passes through the point -4 and -6, what is the numerical value of sine of theta? All right, so what's happening here is, all right, I'm going to actually extend quadrant theta because I'm thinking ahead. If it's going through the point -4 and then -6, okay, basically what happens is, I mean, I'll draw this out. You don't need this whole thing, but we have an angle, right? An angle opens here. It starts here. Here's our initial side. And it opens, and it winds up here in the third quadrant, going to the point -4, -6. Now, to be honest, what we don't need, I'm going to erase a little here. Let me just get this eraser tool. I hope I don't erase other things I need. I'm going to just kind of get this stuff out of my way. Okay. And I'm even going to get this out of here. Really what we're concerned with is the terminal side of this angle that we have right here. Okay, so this terminal side right here can be used to create a bow tie triangle in the third quadrant. Okay, so here's my right angle, and here's my reference angle. I'm going to call it theta. And what we know is since we had to go back 4 and down 6 to get to this point, even though we went back 4, it's a triangle. You can't have a negative length, of a side of a triangle. So the length of this side is going to be 4. And then since we went down 6, the length of this side of the triangle would be 6. And we're going to do a squared plus b squared equals c squared to find the hypotenuse, to find the remaining side. So if I do 4 squared plus 6 squared equals c squared, once I solve for c, that will be my hypotenuse. Okay, and keep in mind, you can use this 4 is A and this 6 is B, or vice versa. The two smaller sides, it doesn't matter which is which. But the longest side of the hypotenuse always has to go in for C. All right, so 4 squared is 16. 6 squared is 36. And if we add those together, it gives us 52. Now, 52 is not a perfect square. So when we do take the square root, we want to write that in simplest radical form. So that'll break up into what? Radical 4, radical 13? So 2 radical 13. And over here, I'll just bring down the C. Okay, so 2 radical 13. Now, I want to label my sides. If this is our angle, the side across from it is the opposite. Oops, sorry about that. That was a really bad O. The side across from the right angle is always the hypotenuse, right? So this has to be the hypotenuse. It's always the longest side. And the side next to the angle we call the adjacent. Okay, so if we think about SOHCAHTOA. All right, they want us to find sine of theta. So we're using this, okay? Sine of theta is equal to opposite over hypotenuse. Okay, that's where this comes in, opposite over hypotenuse. And because we're in the third quadrant, ready, all students take tan, and its reciprocal trig function, cotan, or what's positive in the third quadrant. So I'm going to put a negative sign in front of this. Now let's just plug in our numbers. So sine of theta equals negative, the opposite is 6, and the hypotenuse is 2 radical 13. All right, now here's the deal. You don't want to leave yourself with a radical in the denominator of the fraction, so we know we rationalize it, right? We multiply the top and the bottom by radical 13. All right, so that's going to leave us with negative, on the top, it's just negative 6 radical 13. And then in the denominator, since radical 13 times radical 13 is 13, we have to do 2 times 13, which is 26. Now, we're actually not done because look at that. You can simplify, right? This 6 over 26 would simplify to 3 over 13. So I'm going to rewrite this as negative, and then 3 radical 13 over 13. And that is our answer. If you look on the answer key, I actually did it, I think, through a little shortcut. I mean, I could have just from the beginning, 6 over 2 is 3 over 1. So I made this a 3 and this a 1. And then I didn't have to simplify later on. I did it earlier on. But either way, you get the same answer in the end. Alrighty, so number 10 is another bow tie triangle question. All right, so I'm just going to start off by putting SOHCAHTOA up here because we know we're going to need that. SOHCAHTOA. All right, so first of all, let's figure out what quadrant we're in because they don't come right out and tell us. Now, this says cosine of x equals positive radical 7 over 5. So they're coming out and telling us that cosine is positive. And then this is telling us that tan is negative, right? Tan of x is less than 0. So you have to think about which quadrant is cosine positive and tan negative. Well, that's going to be in the fourth quadrant, right? When you say all students take calculus, that C is where cosine's positive, and secant is too, but other than that, nothing else is. So we're going to be in the fourth quadrant. So I'm going to draw a fourth quadrant triangle. So we go diagonally out into the quadrant. We always connect to the x-axis. All right, and this time my angle is an x, so I'm going to put a little x right there. And we know that the side across from it is called the opposite. So let me just label this. This is the opposite. We know the longest side, which is across from the right angle, is the hypotenuse. And the side next to this angle is called the adjacent, right? That's what adjacent means. It means next to. Okay, so let's figure out what we have for our sides here. So this is cosine is equal to radical 7 over 5. Now, since cosine is adjacent over hypotenuse, this has to be our adjacent, and this has to be our hypotenuse. Okay, so our adjacent, and let me just label the triangle, is radical 7, and the hypotenuse is 5. Okay, so now we need to find the opposite. Since the opposite is one of the smaller sides, right, the legs, we can either solve for A or solve for B. It doesn't matter. But 5 has to go in for C. That's our hypotenuse. That's the longest side. All right, so I'm going to do A squared plus radical 7 squared equals 5 squared. All right, so radical 7 squared is just 7, right? A square and a square root cancel each other off. And then 5 squared is 25. All right, and then when we subtract 7 from both sides, we get A squared equals 18. And when we take the square root, 18 is not a perfect square, so we have to write it in simplest radical form. All right, so I could break that up into radical 9, radical 3. I'm sorry, radical 2. Right, 9 times 2 is 18. And then the square root of 9 is 3, so it's 3 radical 2. So that is our opposite. All right, so now we can finally get to the question. The questions want us to find, the first thing they want us to find is cosecant of x. And then the next thing they want us to find is tan of x. All right, so let's start with cosecant of x. Now, cosecant is the reciprocal of sine. So since sine is opposite over hypotenuse, we're going to take the hypotenuse and put that over the opposite, right? Isn't cosecant, you just flip the answer to sine upside down? Okay. Now, in the fourth quadrant, the only two things that are positive are cosine and its reciprocal trig function, secant. So this is going to have to be a negative answer. All right, so this is equal to negative. So the hypotenuse is 5, and the opposite is 3 radical 2. All right, so we want to rationalize that. So since there's a radical in the denominator, I'll multiply top and bottom by that radical itself. So that leaves me with negative 5 radical 2 over, and then since radical 2 times radical 2 is 2, 3 times 2 is 6. All right, and this doesn't simplify because 5 over 6 doesn't simplify. So there's what cosecant of x is equal to. So now let's go to tan of x. So tan in the fourth quadrant is also negative. And since tan is equal to opposite over adjacent, all right, I could take the opposite, which is 3 radical 2, and put that on top. And the adjacent is radical 7, and we could put that on the bottom. We got a lot of radicals with this one. And let's just rationalize this. So in order to rationalize it, we're going to multiply by the radical we see in the denominator of the fraction, by radical 7. So I'm going to multiply top and bottom of this by radical 7. Okay, so that leaves me with negative. Now let's see. 3 radical 2 times 7. Well, we could multiply these numbers underneath the radical to give us a radical of 14. So we're going to have 3 radical 14 on the top. And then on the bottom, well, radical 7 times radical 7 is just 7. And then nothing simplifies, so that would be our answer. All right, number 11. So it says in the accompanying diagram of triangle ABC, the measure of angle A is 30, the measure of angle C is 50, and AC is 24 inches. So they give us all that. All right, what is the length of side BC? So here's side BC. Now, since that's across from angle A, I'm just going to call that side A, right, like little a. So what is the length of that side to the nearest 10th of an inch? Okay, well, let's see. Remember, when deciding whether we're using law of sines or law of cosines, whenever we're working with 2 sides, we do law of sines, and whenever we're working with 3 sides, we do law of cosines. That's a rule of thumb. Sometimes if you're given extra information, you could use either one and then you can make your choice. But if we look here, we're only working with 2 sides, right? We know this side and we're looking for this side. So right off the bat, we know we're going to be using law of sines. Now, when you use law of sines, you have to use the angles across from the 2 sides that we're working with. So this is one side we're working with, right? Side B. I'm just going to put a B on that. So whatever 2 sides we're working with, we have to use the angles across them. So since we're working with side B, we need to work with angle B. And since we're working with side A, we need to work with angle A. Okay? So we're going to use A over sine of A equals B over sine of B. Okay? Even though we know angle C, it's not the angles that help us decide which variables to use in the formula. It's the sides. We're working with side A and side B. Because we could easily find this angle, right? Think about it. We have a triangle. There's 180 degrees in a triangle. So if we add up the 2 angles we know, 30 plus 50, and subtract that from 180, that's how we get angle B. Okay, so 30 plus 50 is 80, and 180 minus 80 is 100. So that means angle B is 100 degrees. Okay, now we're just going to plug in our numbers. So A over sine of A. A is what we're solving for, so I'm going to leave that as an A. And then over sine of, well, angle A is right here, right? It's 30 degrees, so we'll have sine of 30. And then equals, in place of B, that's equal to 24. And that's going to be over sine of angle B, which we just found to be 100. Okay, now what we have to do is just cross multiply. So A times sine of 100 is A sine of 100. 24 times sine of 30 is 24 sine of 30. And then to get the A by itself, we're going to divide both sides by sine of 100. Okay, so sine of 100 is canceled, leaving with A. And then basically what you do is you just plug this in your calculator, and when you do, make sure you round to the nearest 10th. So when we do, we wind up getting 12.2. And also, you have to have your units there. So in this case, the units are inches. So 12.2 inches. Okay, number 12. Let me just slide this up. So in triangle FGH, you can draw this out if you want. That's up to you. I'll just do that. I'll draw it out. So in triangle FGH, so make this F. Doesn't matter what you make. It does not have to be drawn to scale. GH. It says that side F is 6. Okay, so side F is 6. My triangle is definitely not drawn to scale because check this out. Side G is 9. Side G is 9. Okay, so again, it's not drawn to scale at all because this side looks smaller than this side but has a bigger number on it. And the measure of angle H is 57 degrees. All right, so there we go. Which statement can be used to determine the numerical value of H? All right, so we're looking for little side H. Now, remember, here we're working with 3 sides. Do I still have this up here? Yeah, look. Whenever you're working with 3 sides, we know we're going to be using law of cosines. So we know right off the bat, also it's multiple choice and all we see is law of cosines there, but If we didn't have that, we know right off the bat, we have three sides, law of cosines. All right, so basically with law of cosines, this is our general formula. And whatever angle we're working with, see that's the only angle in the formula? That's the side that goes on the left-hand side of the equation. So if we look at our triangle, isn't this the only angle we're working with, angle H? So since we're going to have cosine of H at the end of our equation, isn't H what goes on the left-hand side of the equation? Okay, so it's going to be H squared equals. And then you just take the other two sides and square them. It doesn't matter if we put F first and then G or G first and then F. I'm just going to do 6 squared. I'm going to do F squared plus G squared. So I'm going to do H squared equals F squared plus G squared. And then minus 2 times F times G times cosine of angle H. Okay, so just again, if you look at the original form, whatever angle we're working with is the side that has to go on the left-hand side of the equation. And then the other two sides, it doesn't matter whether you write F squared plus G squared or G squared plus F squared. It's the same thing. And those two variables also go right here. Okay, so now what I'm going to do is I'm just going to look at my triangle and plug in the numbers. Now, H is what we don't know, so I'm going to have to solve for that. So I'm going to leave that as H squared, and then equals, in place of F, I can plug in the 6. So I'm going to have 6 squared, and then plus, in place of the G, I'm going to have 9, so I'm going to write 9 squared, minus 2 times 6, right, that was F, times 9 was G, times cosine, and angle H is 57 degrees. Okay, so now we just have to look at our answer choices, and we have to see which matches up with this. Now, if you look at choice 2, you'll see that that matches up with that. And by the way, if I had reversed these and written 9 squared plus 6 squared, and then a 9 here and a 6 here, choice 2 is equivalent to that. That would still match up with it. So choice 2 is our answer. Okay, so number 13, 2 straight roads, Elm Street and Pine Street, intersect, creating a 40-degree angle as shown in the accompanying diagram. Okay, so John's house, J, is on Elm Street and is 3.2 miles from the point of intersection. All right, I'm gonna have to make this bigger so I can write on that because that's too small for me. Okay, so this is 3.2 miles. I'm not even gonna fit miles, I'm just gonna put 3.2 for now. Mary's house is on Pine Street and is 5.6 miles from the point of intersection. Okay, this, by the way, is the point of intersection. All right, so find to the nearest tenth of a mile the direct distance between the two houses. So we're looking for the distance from J to M, okay? So you can call it whatever you want. I'm gonna call that X. All right, so if you recall, if we're looking at a triangle, if we're working with 1, 2, 3 sides, let me scroll back up here. Whenever we're working with 3 sides, right, that's when we use the law of cosines. So we're using the law of cosines again. Okay, so here's our law of cosines. So since we're solving for, I called it X. So since we're solving for X, I'm gonna put that in place of A. You could leave it as an A if you want, it really doesn't matter. And then equals, now we're technically not using a B and a C, we're using a J and an M. So it really doesn't matter which one you put in for which. I'm gonna put this in for B and this in for C. So anywhere I see a B, I'm plugging in 3.2. I'm gonna square that. If you want parentheses, you could put it, but you don't need it. And then 5.6, I'm gonna plug in whenever I see a C and square that. So it's gonna be minus 2 times 3.2 times 5.6 times cosine. Now this 40-degree angle is this one in here. Okay, so that is the angle that's across on the side we're solving for. So that's the angle that goes here. So we're gonna put 40 degrees. All right, now when we're solving for a side of law of cosines, that's the ones we like. That's the ones that's nice and quick, right? Basically, you plug this entire thing in your calculator exactly like you see it. Please, please, please do not try to plug it in parts, right? Can you do that? Yes. But I know from, years of grading, more people make a mistake when they try to do this in separate parts. Just plug this entire thing in your calculator exactly like you see it. Okay, so I'm going to bring down the x squared, and when I plug that in my calculator, I get approximately 14.14497. Okay, and then to get rid of a square, I just take the square root. So they want the answer to the nearest tenth of a mile. So when I plug that in my calculator to the nearest tenth, I get 3.8 miles. Okay, and there we go. All right, number 14, it says in triangle ABC, I'm going to draw this out. I always draw these out, right? All right, so there we go. It's a pretty bad triangle, but there it is. In triangle ABC, the measure of angle A is 32 degrees. Side A is 12. So remember, if this is angle A, side A is across from it. And side B is 10. So if this is angle B, side B is across from it. Okay, so they want us to find the measures of the missing angles and side of triangle ABC. All right, well, let's see what we can do first. Now, I'm just saying, if you wanted to try to find this side first, unfortunately, you wouldn't be able to, because whether you use law of sines or law of cosines, if you want to find a side, you have to know the angle across from it, and we don't know that. Okay, so I think what we're going to do is we're going to have to start off finding angles. Now, the first angle we're going to have to find is angle B, because as far as angle C goes, whether you want to use law of sines or cosine, if you want to find an angle, you have to know the side across from it. Or if you want to know the side, you have to know the angle across from it. So we don't know anything about C, so we're going to have to avoid that for now. So what we're going to find first is we're going to find B, angle B. Now, remember what we said on the last 3 problems, okay? Whenever you're working with 3 sides, you use law of cosines. Whenever you're working with 2 sides, you use law of sines. Now, we're not working with 3 sides because we don't know this one, and we can't find it yet. So really, we're working with 2 sides. So when you work with 2 sides and 2 angles, we're going to be using law of sines. So I'm going to do A over sine of A equals B over sine of B. Okay, so for side A, we have 12. And that's going to be over sine of, well, for angle A, we have that as 32 degrees. And that's going to be equal to B, which is 10, over sine of, and I'm going to leave that as a B, right? Isn't that what we're solving for? We're solving for angle B. All right, now let's cross multiply. So we'll have 12 times sine of A equals 10 times sine of 32. And since we're solving for angle B, right, this is sine of B. We have to get the sine of B by itself. So to get rid of this 12, I'm just going to divide both sides of the equation by 12. All right, so that's going to leave me with sine of B. And then this you could just plug into your calculator. All right, so if you plug in 10 times sine of 32 divided by 12, it gives me approximately 0.4416. Okay, so now this is what sine of B is equal to. What we want to do is we want to find the measure of angle B. So what we're going to do is in our calculator, we're going to type in second sine of 0.4416. What that basically is doing is it's taking the sine inverse, right? We show this work on our paper, sine inverse of 0.4416. Okay, this is supposed to be a negative, but it's not coming out. There we go. Okay, so again, in your calculator, typing in second sine of the answer that was there, second sine of 0.4416. And when you do, they want you to round to the nearest tenth. So I am getting 26.2 degrees. Okay, so this is the measure of angle B. All right, I'm going to go ahead and put that in my triangle. I'm going to do a different color because it wasn't given to me, but the measure of angle B is 26.2 degrees. Okay, well, actually, now that we know that, right, if you know 2 angles of a triangle, it's super easy to find the third angle because we know a triangle adds up to 180 degrees. So if you add up the 2 angles you know, all you have to do is just subtract them from 180, and that will give us angle C. So let's do that. All right, I'm going to go to a different color so my work doesn't blend all in together. All right, so I'm going to add up the two angles we know, so 32 plus 26.2, so that'll give me what, 58.2? And if I subtract that from 180 degrees, just like that, so I can do the math in my head, that's going to wind up giving me 121.8 degrees. Okay, so 121.8 degrees is the measure of angle C. All right, so let me put that over here, 121.8 degrees. All right, well, that looks pretty bad. I'm going to actually do that a little better. Okay, so now we know all three angles, and we know 2 out of the 3 sides. So if we want to find the third side, you could do one of 2 things. You could do law of sines or law of cosines. We have enough information to do any of them. Okay, if you want to do law of sines, you could do, for example, C over sine of 121.8 equals, doesn't really matter, 12 over sine of 32, right? You could do C over sine of C equals A over sine of A. Or you could do C over sine of C equals B over sine of A. I'm actually going to do law of cosines just to kind of change it up because we already have a law of sines right here. All right, so if you wanted to do law of cosines, right, we're looking for little c. So if we're looking for little c, the c is what's going to go by itself on the left-hand side of the equation. So it means on the right-hand side of the equation, we're going to have a squared plus b squared, the other 2 variables, minus 2 times a times b times cosine of whatever side goes here is the angle that goes over here. So it's going to be cosine of c. And let's just plug in our numbers. So c squared equals, all right, so we know a is 12, so we'll write 12 squared. We know b is 10, so we'll write 10 squared. And then minus 2 times a, which is 12, times b, which is 10, times cosine of angle c. Isn't this angle c what we just found? 121.8. All right, when you're solving for a side with law of cosines, it's not really too much work because your calculator does the majority of it for you. What you're going to do is you're going to plug this entire thing in your calculator. Okay, and when you do, you get approximately 370.4694. And then all you have to do is take the square root and round to whatever they say to round to, and we are finished. Okay, so they say again to round to the nearest tenth. So here, to the nearest tenth, it would be 19.2, and they don't tell us the units, so I'm just going to write the word units, because you have to label units, right? You can't just leave it blank. So C would be 19.2 units. Okay, and that's it. All right, number 15. So it looks like now we're getting into trig equations. All right, number 15 is a first degree equation. And if you look on the back of the page, I believe the next one, or the next 2, are second degree equations. Okay, so with number 15, if you have a first degree equation, I mean, basically all you're doing is trying to get cosine of theta all by itself. So I'm first, let's see if I could, you know what, instead of writing small, because it's always hard to do on this iPad, I'm just gonna make this bigger. Okay, so first thing I'm gonna do is I'm going to add 1 to both sides of the equation. So that leaves me with 2 cosine of theta equals 1. And then to get the cosine of theta by itself, we're just going to divide by 2. So those cancel, so it leaves me with cosine of theta equals 1/2. Okay, now, what we need to do is, we need to find our reference angle. So to find our reference angle, we need to figure out cosine of what angle is 1/2. Now, we should already know that, right? We should know that cosine of 60 is equal to 1/2. But if you want to stay consistent with how, like, you know, we do trig equations, right? If you wanted to in your calculator, you could type in second cosine, so cosine inverse of 1/2. And when you do, it'll give you that 60-degree angle. Now, this is our reference angle. That's not necessarily the answer. We have to look back to the previous step and say, oh, look, this is positive 1/2. Since cosine is equal to positive 1/2, we want to figure out, well, in which 2 quadrants is cosine positive in? So cosine is positive in quadrants 1 and 4, right? All students take calculus. So everything's positive in the first quadrant. And by the time you get to that last quadrant, the fourth quadrant, calculus C for cosine, okay? So cosine's positive in quadrants 1 where all is positive, and quadrant 4 where there's a C. Okay, so we're looking at the first quadrant and the fourth quadrant. Well, the reference angle, the reference angle rule for the first quadrant is just theta, okay? Theta is just equal to the reference angle itself, so 60 degrees. Okay, and then in the fourth quadrant, our reference angle rule there is 360 minus theta. So if we do 360 minus our reference angle of 60 degrees, that's going to give us 300 degrees, and that would be our answer. And these are really easy to check in the calculator. I'm just going to show you how to do that real quick. Okay, so basically what I did was I took this answer of 60 and I substituted it in for theta. 2 cosine of 60 minus 1. Okay, 2 cosine of 60 minus 1. And when I did, check this out. I got 0, just like the right-hand side of the equation says. Okay, then I wanted to take the 300 and check it. So I put it in place of theta. So 2 cosine of 300 minus 1. And that's what I did here. And when I did, look at that. It checks out to give me 0. So those two answers check. Okay, so number 16, they want us to solve each equation to the nearest degree. All right, so if we look at this, I mean, this is a quadratic equation, right, with cosine in it. And since the equation is already set equal to 0, we could just jump right into using the quadratic formula. Okay, now, here's the quadratic formula here. Now, be very, very careful with this, okay? We don't have an x in our equation. If this said 8x squared minus 2x minus 1, we would write x equals. Because we have a cosine of theta in our problem, be sure to replace this x with cosine of theta. All right, I'm going to do this off to the side. So cosine of theta equals, and then we know our a is 8, our b is -2, and our c is -1. Okay, so we have cosine of theta equals negative b. So -2 would be +2 plus or minus the square root of b squared, so -2 in parentheses squared. If you just want to write 4 instead, that's fine. Minus 4 times a, which is 8, times c, which is -1. And that whole entire thing has to be over 2 times a, so 2 times 8. All right, so we have, let's rewrite cosine theta, and then equals 2 plus and minus. All right, so you want to figure out what that's equal to under the radical. So that's equal to 36. So we have the square root of 36 over, and then 2 times 8 is 16. All right, well, we know that the square root of 36 is 6. I'm just going to cross this off and make it a 6. All right, so what we have at this point is cosine of theta equals, well, it's up to you if you want to simplify this or not. You don't have to at this point, but if you look, we have a 2, a 6, and a 16. They're all divisible by 2. So if you want to divide them each by 2, the 2 becomes a 1, the 6 becomes a 3, and the 16 becomes an 8. Okay, so from here, I'm going to branch off my 2 equations. And you know what? Let me get rid of this just to give myself more room. Okay, so let me just put a line coming down like this. All right, so on the left side, we have cosine of theta equals, well, let's figure out. 1 plus 3 is 4, and 4 divided by 8, 4 over 8 simplifies to 1/2. So on this side, we have cosine of theta equals 1/2, positive 1/2. Okay, on this side, we're going to have cosine of theta equals, well, this time we're going to do 1 minus 3 on top. So 1 minus 3 is -2, and -2 over 8 simplifies to -1/4, or -0.25, however you want to write it. Okay, either way is fine. All right, so let's start with the left side over here. Now, we should already know cosine of what angle equals 1/2, right? We know cosine of 60 equals 1/2. But if you were to do this in your calculator, right, and we want to find, let's label this the reference angle, because this is not going to be our final answer. In your calculator, you would plug in second cosine, right? Cosine inverse of 1/2. And when you do, you get the angle we already knew, right? 60 degrees. So this is called our reference angle. Now, if we come back to this step, right? Cosine is equal to a positive number. It's equal to positive 1/2. Now let's think about all students take calculus, right? Cosine is positive in quadrants 1 and in quadrants 4. So we want to find the first and the fourth quadrant angle that corresponds with a reference angle of 60 degrees. All right, well, the rule in the first quadrant is just theta, right? Theta is just equal to, the angle is equal to just whatever the reference angle is. So this is just going to be, since the reference angle is 60, that is going to be our first quadrant angle. Okay, so 60 degrees is one of our answers. Okay, and then here in the fourth quadrant, the rule is 360 minus theta, 360 minus the reference angle. So if we do 360 minus, and the reference angle is 60, 360 minus 60 is 300 degrees. Okay, so that's going to be our fourth quadrant angle. Okay, so we wound up with two answers over here. Okay, now if we go to the other side over here, where cosine of theta equals negative 1/4, if we want to find the reference angle, and I want you to always write this out, right? Show all your work. We're going to write out cosine inverse of, now don't ever plug the negative in the calculator when you're solving an equation like this. We want to do cosine inverse of positive 1/4. Okay, cosine inverse of positive 1/4. So in your calculator, you type in second cosine of 1/4, and to the nearest degree, right? They want us to round to the nearest whole number. We get 76 degrees as our reference angle. Okay, now, even though we didn't plug that negative in the calculator, why the negative is important is because it tells us which two quadrants to look in. Since cosine is positive in the first and fourth, if on this side we want to figure out, well, what two quadrants is cosine negative in? It's going to be negative in the other two quadrants, right? Quadrant 2 and quadrant 3. All right, so the second quadrant reference angle rule is 180 minus theta. That's a minus. So if you do 180 minus 76, you wind up with, I'll fit this, I guess, down here, 104 degrees. Okay, so that's our second quadrant angle that goes along with the reference angle of 76. Now in the third quadrant, I know our third quadrant reference angle rule is, theta minus 180, but when you're solving these equations, right, we're actually looking for the theta. We're actually, so we discussed in class how it's easier to just do, instead of doing theta minus 180 equals 76, it's actually easier just to use this rule, 180 plus the reference angle. Okay, I'm gonna let theta represent the reference angle here. So if you do 180 plus 76, you wind up getting 256 degrees. So with this equation, we wound up with 4 answers. You can leave it like this, or if you prefer to write out a solution set, I mean, if you do it like this, if you write out a solution set, you want to write your angles in order from least to greatest. So I'd start off with 60 degrees. Then our next biggest angle is over here, which is 104 degrees. The next biggest one is 256. And then our biggest one is 300 degrees. Okay, so if you want to put them as one big solution set, you can do that, and then that would be your answer. All right, and then letter B. So when we look at this, right, we do have a quadratic trig equation, but the first thing we have to do is we have to get one side of the equation set equal to 0. So I like to have my leading coefficient, like my number in front of the square term, be positive. So I want to leave this term on the left-hand side of the equation. I'm going to take these two terms and move them to the left. Okay, so I'm going to subtract sine of theta. That's supposed to be a subtraction sign. And I'm also going to subtract 2. Now, because I'm doing it on the left-hand side, the right-hand side of the equation, I also have to do that on the left-hand side of the equation. So I'm going to subtract sine of theta, and I'm going to subtract 2. Okay, so on the right-hand side of the equation, those cancel. And on the left-hand side of the equation, 3 sine squared theta minus sine theta minus 2. Nothing is a like term. This is a squared term. This is not, and this is just a number. So I'm going to leave it like I see it. So 3 sine squared theta minus sine theta minus 2. And then I'm going to bring down the equals, and since everything cancels on the right-hand side of the equation, it equals 0. To be honest with you, I think it's almost more confusing to write this out. I would just take this, bring it down. If you have a sine of theta, when you bring it to the left-hand side of the equation, it becomes negative sine of theta. And if you have a positive 2, When you bring it to the left-hand side, it becomes -2. All right, anyway, so if I'm going to use the quadratic formula, this is my A. -1, there's like a 1 in there, is my B. And then -2 is my C. Okay, now when we write the quadratic formula, remember, we don't write x equals. This isn't an equation with x squared. It's sine squared. So we need to write sine of theta equals, and I'm just going to plug the numbers right in. So it's -b, so -1 would be +1, plus or minus the square root of b squared, so -1 in parentheses squared, minus 4 times a, which is 3, times c, which is -2, and that whole entire thing is all going to be over 2 times a, so 2 times 3. All right, so we have sine of theta equals 1 plus and minus the square root. So basically, if you figure out what this is equal to under the radical, it's equal to 25. And that's going to be over 2 times 3 is 6. Now, since the square root of 25 is 5, I'm going to cross that off and just make it a 5. Okay, so we have sine of theta equals 1 plus and minus 5 over 6. All right, let me move this up a little. So now I'm going to just branch off my 2 columns here. All right, so on the left-hand side, we're going to have sine of theta equals, well, 1 plus 5 is 6, and 6 divided by 6 is 1. So we have sine of theta equals 1. Okay, and then on the other side, we're going to have sine of theta equals, and then 1 minus 5 is -4, and -4 over 6, here, I'll write that down, -4 over 6 simplifies to -2/3. All right, so let me come back over here to the left. I'm going to start on this side. Now, sine of theta equals 1. Whenever sine is equal to 0, -1, or +1, we want to think about our unit circle. So let me draw that out. I'm going to draw out the unit circle. Okay, and here we go. And we want to figure out where does sine of theta equal +1. Well, sine is the y-coordinate, okay? So when on the y-axis are we up at +1? Right here. Okay, the coordinates of this point are 0, +1. Okay, we went over 0 and up 1 to get there. So this is where sine with a y-coordinate equals 1. Okay, and this occurs at 90 degrees. All right, so that's the only time that the y value is equal to 1 on the unit circle, right? Here the y value is 0, here the y value is -1, here it's 0 at 90 degrees is the only place that sine of theta is equal to 1. So on this side, we only get one answer, okay? Theta equals 90 degrees. Okay, now over here, let's see, we have sine of theta equals -2/3. Now, what we want to do is we want to take the sine inverse to find our reference angle, right? Reference angle. We want to take sine inverse of the positive of this value. So we're going to take sine inverse of +2/3. Okay, we never plug in our calculator when we're solving trig equations. We never plug the negative in the calculator. The negative is just going to tell us which quadrants we're working in, which we'll get to in a minute. So when you plug in sine inverse of 2/3 to the nearest degree, I'm getting 42 degrees. Now that's not our answer, that's the reference angle, okay? What we need to do is we need to look back and say, look, here sine is negative. If we think about all students take calculus, sine is positive in quadrants 1 and 2. So it's negative in quadrants 3 and 4. So we need to find the third and fourth quadrant angle that goes along with a reference angle of 42 degrees. Okay, so in the third quadrant, we know that when we're solving trig equations, rather than using theta minus 180, we do 180 plus the reference angle. So if we do 180 plus 42, 180 plus, this is the reference angle, right, theta, that's going to give us 222 degrees. So that's our third quadrant angle. And then in the fourth quadrant, we know the rule is 360 minus theta. So if we do 360 minus 42, that's going to give us 318 degrees. Okay, so for this question, we actually have 3 answers. If you prefer to write them in a solution set, like you could do this. You could say, all right, so we wound up with, always write them from least to greatest. So we wound up with 90 degrees, 222 degrees, and 318 degrees. But you don't have to put them in curly brackets. You could just leave them circled like we had before.